Hi there, my name is John Pagliata, and I manage an R&D group here at Vector. My group focuses on new ideas for improving software testing and software quality, and my topic today is how communication and collaboration affect software quality. So I'll be talking about areas where communication and collaboration often break down on software teams, and some ideas I have that I hope you can use to improve things on your project.
All right, so let's just dive into the slides. So there'll be 4 sections, a small introduction with some terminology, and then 1 section on improving communication, 1 section on improving test collaboration, and then a single slide summary, and I'll be happy to take some questions at that point. So my first slide, just some definitions, not because I don't think you know what communication and collaboration mean, but I think it's good to think of the strict definition in terms of how it applies to software. So communication, exchanging information, right? It's something we do all day, every day when we're on a software team. And then collaboration, working with someone to produce or create something. So exactly what we're trying to do with software products, create something that's hopefully interesting to our customers. So just continuing, over the last 20 years, software teams have grown quite a bit in size. So today's teams are large and distributed geographically, probably with COVID even more distributed than they were pre-COVID. Team members have become specialized, right? So we've got designers, developers, and testers. So you might have a variety of other roles, but those are the 3 that I commonly refer to. And so this team size increase has led to communication problems. I mean, as far back as 98, this is an old example, but it's a really famous one that people like to use because it was such a breakdown in communication. So basically, there was a Mars Climate Orbiter, if you're not familiar with this. It was launched, but in the software development, JPL used metric units for force, and Lockheed used imperial units. And so obviously there was a disconnect there, and they're not quite sure what happened. Either the probe bounced off the atmosphere and went into orbit around the sun, or it burned up in the atmosphere. So if you think back, I mean, if you've been in software development for 20 or 30 years like I have, even the early tools were really focused on solving some of these communication problems, right? So maybe one of the first tools or tool types that was out there were data dictionaries. So just trying to bring together all the different types in data values that were going to be used in a project, so you didn't have the crazy bugs like, hey, I said 0 is true and you said 1 is true in your handwritten document. And requirement tools obviously were an early tool, and even modern tools really are about collaboration and communication, right? So we've got tools like Confluence and Jira to share the plan with your team. Source code control obviously has been around for a long time, but GitHub has brought it to, and Git in general brought it to another level of being really good at merging changes from multiple people. And then you have tools like Jenkins for continuous integration to share your testing and build infrastructure. So where are the gaps? Well, I think the biggest gaps are in 3 areas: requirements, testing, and bugs. And so for requirements and bugs, we're still primarily using human language to define what we want the software to do, and human language to describe what happened or what went wrong for the bug. And then for testing, we're not really sharing test methods and test cases. Every group, every subgroup, so the designers, the developers, and the testers each have their own flavors of tests that they're interested in running, and probably their own tools. So I think the 2 key communication challenges are human language, as I mentioned. So you have key information is embedded within unstructured text, and then the information is kept in silos, so different parts of the team own different information. And then test collaboration. I think, a common thing I hear from customers in the field is, we don't control those tests. They get run by a different group, maybe later in the process. And then for sure, different groups use different tools and processes. And so those are the key areas that I'm going to dive into a little more in the remainder of this presentation. So let's talk about improving communication, some ideas for that. So the first challenge, I think, is that designers will write requirements primarily in human language. I'm sure there'll be tables in the documents, and there might even be some files with data in them. But in general, a lot of information is just encoded in sort of human language. And the problem with human language is multiple people will interpret the same requirement differently. And I think, any of us who write anything, we always think what we write is clear, and then other people probably disagree. And so then developers read the requirements and they fill in the blanks, right? So anything that's ambiguous in their mind, even if the designer didn't think it was ambiguous, they'll sort of fill in the blanks, and not in a malicious way. It's just, okay, I'm not certain what this means exactly, or I'm pretty certain this is what they meant. And developers also tend to think in terms of happy paths, like they think in nominal workflows, and I'll have an example of that in a little bit. And then testers, they'll also read the requirements and they'll fill in the blanks. So anything that's ambiguous in their mind, they'll fill in the blanks, and they may or may not have the same thing in mind as the designer or the developer. And also testers tend to think in terms of, hey, let's break this. So they automatically think of, hey, anomalous cases or something weird that might happen. And then testers write bugs, describing what's wrong, and again, using human language, which we already agreed sort of is imprecise. And then customers, on the other hand, just want things to work. And so generally they find issues with speed and scalability because maybe the designers, the developers, and the testers, nobody thought of how big the real world use case might be for something. So now let's have a small example of the language problem. Here's a sample requirement. Given two files with lines formatted as key, list of values, compare the files and generate a differences report. So seems pretty simple, but what's missing? What's missing is, what's the delimiter? So I don't know, I might think of lists as being space separated. You might think of lists as being comma separated. So probably the developer and tester will each think of their favorite list delimiter and assume that makes sense. And then suppose a key is not in both files. What do we do? Well, the developer might say, ignore. I'm trying to show the differences in the list of values, right? So if the key is not there, they're all different. And why would I display that? And the tester might say, hey, you should report that as maybe the file is improperly formatted. So during this process, during development, we get bugs of that nature. We get bugs where people have filled in the blanks, as I said, and come to different conclusions. And then when the application actually gets deployed, you get these other flavor of bugs. So maybe the designer, the developer, and the tester all thought that order doesn't matter for the values in the value list, but maybe the customer thinks order is important. Think of compiler options. Usually order matters. And then how many lines in a file? Again, the developer and tester might think, well, these files are pretty small. They're going to be maybe 100 lines. And, turns out the customer's thinking of files with 10,000 lines in them. So that's an example. And now let's think about how we can improve things. So I think we can improve things by everyone pitching in, right? So it's not one person's job on a project or one group's job to improve things. We all have to collaborate, right? And so that's why I think that communication and collaboration are really closely related. So what can the designer do to help? Well, they can define the requirements with examples and spend a lot of time thinking about edge cases, because we all know that's where the bugs come from, with unanticipated combinations and edge cases. So, much better than just the text they wrote. I think the text that was in the previous slide is fine as a high-level description of what's being done, but let's augment that with a set of files which contain various key and value list combinations. Because if I'm a developer and you give me 3 sets of 2 files and I look through them, I'll pretty quickly understand the scope of the problem. And I know, some of you are thinking, well, most embedded applications at least don't have a file-based input. So the file is sort of arbitrary here. If it's not a file, then at least we can create tables of input values. Also, it's important for the designer to think about worst case examples, right? So what's the biggest file likely to be seen in the field? And maybe there's some interaction with customers that needs to happen this early in the process. Next, the developer needs to formalize any fill in the blank stuff they do, any implementation decisions they do with test cases. So every conditional in the code should have 2 test cases, and that's why one of the popular types of code coverage is branch coverage, right? You want to test that every decision point in the code has been tested both true and false. And so if you write something like if left tag in right tag list, then obviously we need to have 2 files where the tag is in the left and not in the right. And same thing for the next example. And then the testers and the support folks, they need to attach a set of files. Again, for our simple example where we're comparing files, each bug report should have a set of files that duplicates the problem. Until there's a test or an example, you're not ready to create a bug. So if you just have a text language description of a problem, you're really doing a disservice, and you're going to lead to the developers, and you're going to lead to a lot of back and forth, probably a ping pong match of, hey, I can't repeat this. Yes, it is a problem. No, it's not a problem. The next communication challenge is silos. So I think it's pretty common to have lots of information stored in lots of different silos. And I think the common ones are, you've got your requirement silo, your source code, your test cases, your bug reports, and lots of information in the different engineers' brains, right? And so I don't think this is necessarily bad. I think every flavor of information has a logical group to maintain it. And the key, though, is when this information is not shared easily. And so how many times a day do you ask someone a technical question? Probably lots, right? All of us are sort of in this collaborative development environment. We have stand-up meetings. We walk around. Well, we used to walk around our cube farms and ask people who were the most knowledgeable about something, hey, how does this work? Or who knows how this works? And so one of the questions is, how many times do you get an answer back which refers you to a place where it's documented versus how many times is it, oh, Bob knows about that? And so I think one of the things is we need to get some of this critical information into a silo that's just floating around in engineers' brains. So we want the communication without friction, right? Teach a man to fish, don't feed him a fish. And we want to make it easy for information to be shared so it's obvious where the information exists and which is the single source of this information. And that's what I'm going to get into next as a topic. So here's an example silo problem, right? How does this API work? So if you're building a library, you probably want to document the API parameters and the ranges of values for each parameter, something of that nature. Again, this is a simple example just to make my point. So, if a question comes in from a customer, support might read the user guide and say, hey, I tried what it says in the user guide, but it doesn't seem to work. Designers would go back to the requirements and say, no, it's supposed to work that way. The user guide's right. And then the developer looks at the code and says, oh, those requirements are out of date. Remember, we had this change request, so we changed how it works. This is how it works now. And then the testers run the application to see what really happens, and they're like, oh, this is what it really does. So this is sort of a super simple example of how siloed information is not really an efficient way to store things. So even in this trivial example, there are really 2 problems. Accessibility to the data and duplication of the data. As you can see in my example, we've got data in the user guide, we've got data in the requirements, we've got data embedded into the code, and we've got data in the test cases. And that's the crux of my argument, that having this data in silos isn't so bad, but we really want to allow the data to be accessible across the team. And a key point is that the data is not duplicated, right? So if it's duplicated, then we're going to have a slightly different version of the data in the places where it's duplicated, and that makes no sense to me. So think of another simple example is Doxygen. If any of you are doing C or C++, you're probably familiar with Doxygen. It's widely used in those languages. Other languages have other sort of self-documenting tools. And so if you don't know Doxygen, basically the big idea is at the time that the developers build an API, a class, or a function, they just include sort of structured English for these comments that are prefixed with triple slashes. And then the tool, Doxygen, is able to parse these special comments with the special tags like @param and to build beautiful HTML documentation. So the beauty of this is, okay, at the time that I'm changing the parameter type for time in this example, then I'm probably going to remember to update the Doxygen comment. And then, hey, we get perfect documentation for this just in time without duplication. So if you think about what Doxygen is doing here, really it's providing a single source of truth. And this is a phrase that's gained traction in IT over the last many years. So what it means is that each data item should really have a single place that you look for it. So we talked about data being in silos and being owned by different people. Again, that's completely fine to me, but we shouldn't duplicate the data. So the same sort of data item shouldn't exist in multiple silos. So the key point is, sure, maintain the data item in a silo, but one silo, and then give others a window into that silo so that they can make good use of it. And so here again is a simple example of that. You know, lists are a perfect example because any software application you ever work on will have some things that exist in a list format. So again, this is one simple example just to extend on the Doxygen API example. So you might have a list of colors. And so the designer is going to build a requirement document with a list of colors that are valid for the application. And so rather than him or her just embedding these in a paragraph of unstructured text, why don't we actually create a colors.txt file that gets appended to the requirement? And then the beauty of that is once we have that in electronic form, the developers can build a script to auto-generate their header file. So again, just using C as an example, if you're using other languages, obviously it would be very similar. Most languages support enumeration. So if we can auto-generate colors.h from the colors.txt file, then we know the code will never be out of sync with the requirement. And then further, if we then use colors.h as part of our unit testing, we know that the test cases will always have access to the correct set of colors. And the fourth step is if we can write a little more glue, we can actually auto-populate the paragraph in the user guide that pertains to colors based on that same information. So we've gone from a Word document that has a comma-separated list embedded in some paragraph of text to a single file that's going to be the genesis for every place in the application where we use the list of colors. Okay, so the next section is for improving test collaboration. And there are a lot of areas we could talk about collaboration in software development, but I think test collaboration to me is an area that's really lacking. And so what are some of the challenges of test collaboration? I think one of them is the idea that these tests get run, these fill-in-the-blank tests get run later, often by a different group. So two problems there. One is different groups owning different tests. So this is an example of siloed data that I think needs to not be, the silos don't need to be maintained, they need to be broken down. And I think that in general, testing and quality must be part of your team's core competency, right? So everyone has knowledge to contribute to the test cases, and it's ideal if everyone is free to do that without a lot of friction. Another common thing we hear is that, we don't have access to the tools they use, or we don't have access to the target boards that are needed, or a lot of these excuses for why testing can't be shared. But I think it's really time that we break down these test silos and expose all of the tests that we own as a project to all of the different stakeholders. So I think it's fine for tests to be maintained by multiple groups. I think it's fine for them to use different tools, right? It's it's very unlikely you're going to find one tool that's perfect for every flavor of testing you need to do. So different tools are not the problem. Test maintenance being done or even test generation being done by multiple groups is not really the problem, but the lack of a common way to control the test execution and understand the results, to me, that's the problem that we should look at solving. So if you just think for a minute, we've, 3 basic flavors of testing: unit, integration, and system testing. The techniques are going to vary widely. You're close to the code here, so you're going to write code or you're going to use a tool that provides a framework for that. Integration, you're a little further away from the code, but still pre-functional testing, so you're going to probably have scripts and custom things that help with that. And then system testing, you might have some automation for that or have people actually pushing buttons to do your system testing. So we can just capture basically this situation, what I call the fragmented testing approach in this slide, right? So you've got your developers. Again, you'll have multiple more flavors of these maybe, but just to keep it simple, you'll have your developers doing the unit testing and maybe your dedicated test group doing the integration testing, and then maybe the system engineers, designers doing your system testing to make sure things conform to the requirements. And hopefully by now everybody has their test cases existing in SCM along with the source code, and this is pretty common what we see in our customers. And so how can we unify the process? Well, the first thing we need is a common testing platform, not a test implementation platform, but an overall test interaction platform. We need, most importantly, a single way to execute tests, so it's simple. We don't have to learn end tools, and a single place to view the results, so we don't have to scavenge around our repositories for that. And then we need an API to be able to access all of the data produced during testing programmatically. And so what are the key building blocks? To me, the key building blocks are test editing. So this should be simple. Even if we can't, at the start, share test editing, that's not critical to me that we can share test editing, but still within the group for the unit testing or the integration testing or the system testing, it should be simple for those people knowledgeable about that flavor of testing to do editing. And then the inputs obviously need to be text-based for compatibility with SCM so that the tests can move along with the code. The test execution, this is a key improvement. It has to be push button. I don't mean from a GUI, but it has to be simple to run a test, fast, and debuggable. I think people lose sight of the fact that they need to make their testing debuggable when they're designing their test environments. And then the test reporting has to be web-based. I mean, there are so many frameworks that you can find for creating quick dashboards that there's no excuse for your test reporting not to be published via the web. And then the results are critically important so you can see trends over time. So let's save those into a database that'll scale. So my 2 takeaways from this are, if you make it easy to create tests, you'll get more tests. If you make it hard to create tests, annoying, you're going to not get many tests. And then if you make it easy to run tests, more testing will be done. So pretty simple takeaway. So how can we improve things? Here's my updated flow graph with a collaborative approach. And so you can see the stuff in red is what got added to the previous slide. So we still have our unit integration and system testing, and I've added in red some of the tools that Vector has that address these different areas. But we've added a test results database on the left side. We've added a web dashboard on the left side so that everybody, testers and everyone else, we're trying to make everybody a tester, right? So everybody can see the status of all flavors of tests via a dashboard. And then the big thing is this test abstraction layer that I call it. And this is where we need a common command line interface for your testers to interact with the test environment. And then we need the very specific tool connectors to connect to whatever tool you're using for the lower level testing. So very important here, I'm not replacing any of your low level tools. Use whatever you'd like. If you're doing hand-coded unit testing, fine, continue doing that. If you're doing bash scripts for integration, continue. If you're doing push button system testing, maybe rethink that. Things need to be automated, right? And then so let's flow that up though into this abstraction layer. to make things accessible to everybody on the project. And then, so how do we adopt an abstraction layer? You're going to get some pushback. So here's sort of an incremental idea I have for doing this. First of all, independent of all the groups at the project level, you need to implement a database and dashboard for test results. And so it's really important to get the data model right, to anticipate the flavor of data you want from your testing and what you want to report, so that you can, in step 2, ask your groups to actually publish that information. So getting them to publish once this database and dashboard are set up, I think you're going to get quick and easy buy-in to this, because it's everybody who's doing any flavor of testing has test results. They might not be in the same format that you want them stored into the database, but that's not a lot of work. So you should be able to implement the database, get a dashboard, and get all your results flowing out to the team. And I think people just getting that step 1 accomplished, I think you'll get really good feedback from your team for them to have visibility, everyone to have visibility, including the managers, into what's going on in your test process. Then the next step is going to be harder, right? So now we're going to ask all the teams to publish a command line interface to allow tests to be run by anyone. And so you're going to get a laundry list of complaints about this. We don't have, if it's embedded, we don't have enough target hardware. We need all the tools installed on everybody's machine. We can't do that. We use Linux for this. We use Windows for this. We can't do that. We can't give everybody a Linux. There'll be a laundry list of complaints about this. But maybe with the advent of virtualization being so easy, what you need to do really is create a virtualized test machine. And if you do that, then it's easy to clone them. You can send them to all the different people. You can put them in a farm where they're just spun up when they're needed. So you're going to get a little pushback on that, but you need to persist, and force maybe is not the right word, but you need to strongly encourage people to go down the exposing their test execution to the rest of the team. And then finally, this would be the hardest, right, is if all of the underlying test mechanisms are controlled by data-driven test cases. And what I mean by that is files, tables that concentrate on the test values and sort of leave the implementation details alone. So if we're testing a sign function, as you can do with VectorCast, then the test case itself is completely disconnected from the implementation details of the test harness. And so anybody really, given a nice, easy editor to use, would be able to set up a set of angles that they want to choose to test the sign function. So data-driven, that's sort of a reach goal. And then once you have that stuff, once you have at least step 2 accomplished, where you have access to anybody being able to easily run any flavor of test, then you can build this sort of test abstraction layer, which has a command line interface to do things like get a list of tests, run a test, debug a test. And then obviously that will also require a little bit of work, maybe a lot of work, depending on the underlying tools being used to build those connectors to the lower level test frameworks. So in summary, final thoughts. Let's get feature descriptions from unstructured text and moved into sort of data files and test cases. Same thing with bug descriptions. Let's extract key data values rather than having them kept in multiple formats and multiple silos. Let's get them into a single source that people can share the test results rather than having them scattered among all the developers, all the testers, all the designers. Let's consolidate them into a single view. And then for test execution, let's get rid of the fragmented approach to test execution and have it all integrated into a nice, easy to use front end. And that's it for me. I'd be happy to answer any questions.